So for the second question, we want to consider a family of Lissajous curves, which are just curves of this form. So xt is sine at for some a larger than 0, which is constant, and yt is cosine of bt. Also b is some constant larger than 0. And we're asked to answer the question, which is for what values a and b is our Lissajous curve RT a closed curve? So what does closed mean? This means that the curve repeats itself. So it forms a closed loop or a closed figure. For example, so we graphed actually in our first discussion in the first week, second discussion in the first week for a equals 2 and b equals 1. So this gives RT is xt equals sine of 2t, and yt is cosine of t. And we saw that this figure this is 1, negative 1, 1 also negative 1. This figure looks like an hourglass. So it's closed because you see that as t goes to infinity, this figure is just going to repeat itself, right? So it's periodic. It's a periodic function in t. Right, so how do we approach this problem? So notice that for any a and b, we have, since x is given by sine of at and y is cosine of bt, at t equals 0, we have x is sine of 0, which is 0, and y is cosine of 0, which is 1. So at time equals 0, we would always start at this point, which is 0, 1, at t equals 0. Excuse me. And so if this curve is to repeat itself, it has to revisit this point, 0, 1. So we have the following observation. So the curve is closed if and only if it revisits point 0, 1. And what does it mean for this curve to revisit point 0, 1? So if sine of at is 0 and cosine of bt is 1 for some t larger than 0, this exactly means revisit because I don't want to count the first time that it visits 0, 1. Then it must mean that at is an integer multiple of 2 pi. At is equal to 2 pi k for some k an integer, and bt is also 2 pi l for some l an integer number. Great. So what is neat? Let's we can now consider the ratio between a and b, which is just the ratio between at and bt, which is 2 pi k divided by 2 pi l, which is going to be k over l. And this is a rational number. So this begs the question, is the converse true? So if the ratio between A and B is rational, then is it true that R of t is closed? And indeed, the answer is yes. And let's show it. So let's suppose that the ratio A over B is Q, rational. So this means A is Q times B. Right. And I want to show that this curve repeats, which means there exists t larger than 0, k and l integers such that at equals 2 pi k and bt equals 2 pi l. And these are basically equivalent to saying that the curve revisits the point 0, 1, which is what we want. Great. So let's just solve for this t to see if it exists. So from these two relations, I can write 2 pi k over a equals t, which is also equal to 2 pi l over b. So this is if and only if. Right? So I have 2 pi k over a equals 2 pi l over b. But I can also I also have the relation, recall that, the relation a equals qb. So I can substitute this a here. So 2 pi k over qb is equal to 2 pi l over b. So I can cancel the bottom b here. I can cancel the 2 pi's. And so I'm left with k over q is equal to l. In other words, this is q equals k over l. Great. So as long as k over l equals q, we have 2 pi k over a equals t equals 2 pi l over b. So this means I actually do have such a solution. And this completes the proof.